All right, so this one says perform the division and then simplify. So the first thing we're going to do is keep, change, flip it. So x squared minus 9 over 24 times 4x plus 12 over 3 minus x. Okay, then I want to go to each spot and see if I can factor. So the top left would be the difference of two squares, x plus 3, x minus 3. And then the top right, you could take it a 4, x plus 3. So these are gone. Then we do the cancel. So 4 goes into 24 6 times. The x plus 3 in the top and the left cannot get canceled, right? They're next to each other. It has to be diagonally. So the only other thing that can get canceled is the x minus 3 and the 3 minus x, and those are opposites. So one gets a negative 1. So it doesn't matter if you put it in the top or the bottom, but somewhere there's that negative, which means in my numerator, I would have negative x plus 3 times x plus 3 over 6, which can be written as negative x plus 3 squared over 6. And then you could have even gone as far as like expand and FOIL that. That would work too, but you don't need to. I would have taken either of these answers. Part of your test is multiple choice, and then part is open-ended. So if this is a multiple choice question, just keep in mind that only one of those answers is going to be there, so you might have to match them, okay? But it is part multiple choice and part open-ended. Yeah. Okay, this is 5. Now we're doing multiplication. So we're going to keep the order, but we're going to go through and factor each part. The top left one, there's a variable at the front and the back, right? But no other terms. So I'm basically looking for the factors of negative 4 that sum to positive 3, but I have to add the y at the end for the last variable. So I'm saying positive 4 and then negative 1. So that's the top one. X plus 4y and then x minus y. Underneath it, I have a greatest common factor, x squared, and then it'd be x plus y. So x squared, x plus y. To the right, the x would get left by itself. And in the denominator, again, like the top left one, you have a variable at the front and the back, but only at the, but no leading coefficient. So you're looking for the factors of 4 that sum to 5, but we want to put a y after those factors. So it would be 4 and 1. And I get x plus 4y and x plus y. So now we start to cancel. The top left and the bottom right both have an x plus 4y. And then the x and the top right cancels with one of the x's from the bottom left. And that's it. X minus y is left in the top. X plus y times x plus y in the denominator, which can also be written as x minus y over x plus y squared. Say again? Oh, yeah, and the x, sorry. There. Any other questions from the homework? Camilla?
Can't you cancel x minus y with one of the x plus y?
No, you can only cancel the minuses if they are both, if they're opposites or the exact same. You can't cancel a minus with a plus. Cool.
Would it be correct if it was, if you just put the x in front of the x plus y times x plus y?
Like here. Oh, yeah, sorry, I left off there. Like that?
Yeah.
Sure, either of those work. Yep, and multiple choice wise, you'll only get one of those. So the good and the bad, folks, is the factoring continues. Okay, now we're using it to add and subtract rational expressions. So we've gone from just factoring to factoring with one fraction, so we can simplify a rational expression, to multiplying and dividing, to now we're adding and subtracting, okay? This process is a little bit more complicated because you got to find a like denominator, okay? But it still is forcing the practice of the factoring, which is obviously a skill that's just going to get repeated over and over again. So when you are adding and subtracting rational expressions, which really just means fractions, okay? They have to have the same denominator. Most of them we're going to end up factoring first, then finding the least common denominator, which means you're going to look at all the denominators and you're going to take each term or expression to the highest degree. That's how you're going to find that least common denominator. Then you're going to multiply each term by what is missing from that denominator to the new least common denominator. And then you'll have your same denominator, so you'll add or subtract the numerators. And the ending answer would have your least common denominator as the denominator. So they look like this, and obviously we start with our basic skills, right? If I have 1/2 and 1/3, I need to give these a like denominator, which what number do both 2 and 3 go into? 6. And so the long way around it is to say, okay, if it's 6, then what? 1/2 equals what over 6? And so we'd multiply here by 3, and we do this by 3, which is 3/6. And we multiply here by 2, so we multiply here, and this is 2/6. So then 1/2 is really 3/6, and 1/3 is really 2/6. The denominator is now the same, so we combine the numerators, and I keep the denominator the same. So we baby step our way into the end goal, okay? Obviously, a question like that is not going to be on your test, right? But we're just reviewing the skills. Then it goes to, okay, now I've got variables involved. Or sorry, let me go to 2. So what's the least common denominator here? 12. So this one only has to change, and it would be 2/12 plus 1/12, which is 3/12, which reduces back to 1/4. All right, now we go ones that have variables in them. So if I look at 3, do they have the same denominator? Yes, all I have to do is combine the numerators. So 1 plus 2 gives me a 3 in the top, and then the x plus 1 stays as the denominator. For 4, there's now a minus between. So you have to be careful with that minus. That minus goes to both the 2x and the negative 3. So the numerator, if I rewrote them out again, would be x plus 1 minus 2x, and then that minus goes to the negative 3, which becomes plus 3. All of it's going over my least common denominator, which is the same denominator. Then I combine my like terms. X minus 2 is negative 1, so that's negative 1x or negative x. And 1 plus 3 is positive 4. And it goes over x plus 2. So watch your signs. That question should be easy, but when people don't distribute their negatives, you get the wrong answer in the top. Just to be clear, still not a test question. We're simply baby stepping our way towards them, okay? Questions on that one? All right, now our denominators are different. This one's still just a product. So I have to figure out what's the least common denominator of x and 6x. What do they both go into? 6x, good. So this one already has it. The one on the left, I have to multiply by 6. So 6 over 6x plus 5 over 6x. So they both had an x to the first. I didn't need that one, but the 6 would be the factor that both 1 and 6 go into. So this becomes 11 over 6x. Now my denominators are 2 completely different factors. X plus 2 and x minus 4 are different factors. So the least common denominator is going to be the product of those. My least common denominator is going to be x plus 2 times x minus 4. So now the way this works, I'm going to show you like the long step at the beginning, and then eventually we're going to cut out a little bit of the steps, okay? But I need to change both of these fractions to have that denominator. So if I have 1 over x plus 2, and it needs to become something over x plus 2 and x minus 4, and then I have 3 over x minus 4, and it needs to become something over x plus 2 and x minus 4. Whatever's missing from the denominator from the original to the new, I'd have to multiply, and technically I'm multiplying by both the numerator and the denominator. So what's missing from 1 over x plus 2? X minus 4. So I'd multiply this by x minus 4, and I'd multiply this by x minus 4. And 1 times x minus 4 is x minus 4. And then I repeat that process for the second one. X minus 4 to x plus 1, x plus 2 and x minus 4. What's that missing? The x plus 2. So this time I'd multiply it times x plus 2. And I would distribute here 3x plus 6. Now this fraction is going to replace this one. And this fraction is going to replace this one. So x minus 4 over x plus 2 times x minus 4 minus, because that's the sign from here, and obviously that's important because it's going to change the signs after it, 3x plus 6 over x plus 2 x minus 4. Now the denominators are the same, so I can combine my numerators. I'd get x minus 4. This minus is going to go to both of these terms, minus 3x minus 6, and it all goes over my like denominator, x plus 2 and x minus 4. And then I combine my like terms, so I've got x minus 3x, so that's negative 2x. And then I've got negative 3 and negative 4, and negative 6, which is negative 10. Over x plus 2 times x minus 4. Now technically, hang on just a second. Now technically I can take out a greatest common factor from the 2x and the 10, but I would only do that if there was a factor in the bottom I could cancel out, okay? So this is the same as negative 2 times x plus 5 over x plus 2 and x minus 4. So I took out the greatest common factor. If it's multiple choice, you might only see that second one, so keep that in mind, okay? If it's open-ended, I would have taken both answers. The only time you would have to do that is, let's say there was like a 10 in the bottom and I could actually simplify. Now you've got to go to that next step. So either of those would work for open-ended. Obviously, only one of them is going to be their multiple choice. So just make sure you're looking through your answers. So, God bless you. So I'm going to, that is the full-on process. That is why we can do what we're about to do, but we are going to eliminate some steps moving forward, okay? So if you're confused and you want to go back to this full-on process, do it, okay? But we're going to try to speed this process up and make it a little less tedious, okay? But that is the correct way to do it, and that's why we can do what we're about to do. So go to 6, sorry. I did go the other way. What's the least common denominator here? Are x and x plus 1 two different factors? Yes. So the combination of the two is my least common denominator. Now, instead of going full on out and setting up both separate ones, all we're going to do is multiply the numerator of each one by what's missing from the denominator of that one. So if I look at the first one and I just focus on my denominator, which is x, what would I have to multiply x by to get to my new least common denominator? X plus 1. So that's what I'm going to multiply the numerator of that fraction by. Only what's missing from the bottom. So 1 times x plus 1 is x plus 1. Then I take the sign from the middle, which is plus. And I repeat that process for the second fraction. What is missing from x plus 1 to my least common denominator, x. So I just multiply 1 times it. And now I combine my like terms in my numerator, which would be 2x plus 1 over x times x plus 1. So instead of changing each individual fraction's numerator and denominator, we're simply going to worry about the numerators. But to know what to multiply the numerators by, we have to look at the denominators. So you're going to find your least common denominator. You're going to figure out what's missing from each fraction to that and multiply it in the numerator. And then combine your like terms at the end. Isabella?
So would it be incorrect if the denominator was x squared plus x?
If it is an open-ended question, no. If it is multiple choice, it won't be written like that. It will be written like that. And you've now just lost 30 seconds off your time. Don't do it. You're going to need every second.
Oh.
Yep. Don't waste time on doing things you don't need to do. Rodrigo.
So we can't like cross simplify because it's addition?
Correct. Okay. Go to 8. Look at your denominators. Are those different factors? So the least common denominator is x minus 3 and 3x plus 4. What's missing from my first fraction? 3x plus 4. So I'm going to distribute that out, and I end up with 3x squared plus 4x. Now the minus comes from here, so minus, and I'm going to start parentheses because this is now going to be more than one term after it, and I have to remember to change the signs of everything after it. What's missing from the second fraction's denominator? X minus 3. So I'm going to distribute a positive 2, so the negative on the front is going to take care of the minus. 2x minus 6. And all of it goes over x minus 3 and 3x plus 4. God bless you. Now I distribute the negative. God bless you. So I get 3x squared plus 4x minus 2x plus 6 all over the same denominator. I'm not going to write it out every time because I know what it is, and I especially will remember if it's multiple choice that that's my answer. But it'll save me time not to write it every time. And then I combine my like terms. So 3x squared, positive 4x and negative 2x becomes positive 2x plus 6. And all of that goes over x minus 3 and 3x plus 4. Now I have one last step, and that is to see if I can factor my numerator. How would I try to factor that numerator? First and last. So 3 times 6 would be 18. Are there factors of positive 18 that add to positive 2? It would be 1 and 18, 2 and 9, 3 and 6. Any of them add up to 2? No. So this is my answer. That top is prime. All right, so 2x minus 1 and x plus 2, different factors, right? Which means the least common denominator would be what? 2x minus 1 times x plus 2. So my first fraction is missing which one? X plus 2. And then I'm going to distribute here, so I'd get x squared plus 2x. Then the minus comes from the minus in between. And the second fraction is missing what? The 2x minus 1. I'm going to put parentheses to remind myself that that minus is going to both the terms after it. Distribute 1, and it's 2x minus 1. And all of it goes over the same denominator. Now I distribute that negative. So x squared plus 2x minus 2x plus 1, because the negative goes to both, goes over the same denominator. And then I combine my like terms, and the positive 2x and the negative 2x cancels. And I end up with x squared plus 1 over 2x minus 1 and x plus 2. Can you factor the numerator? No, that is the sum of two squares, right? If it was the difference, you could factor it. But even then, it didn't cancel, so you didn't need to. You only have to factor if it can cancel. Yeah.
So are you always multiplying your numerator by your opposite denominator, or no?
So, I mean, good segue. When we get into ones that have more than one terms, you may be multiplying by something different. If they are just two and they are two different terms, then yes. But if there is a common term, like if you have an x and an x squared, now it's different. And if they are 3, which we're going to get to in 11, it's going to be different. Okay. Daniela.
Can you see the answer for number 8?
Uh-huh. Now, this is the first time with the binomials that we've had to factor. That bottom left can factor. Excuse me. How does x squared minus 9 factor? X plus 3 and x minus 3. So this is gone now. Now, I have a repeated factor. If they are both to the same power, then I just take that factor and make it part of my least common denominator. Because both x plus 3 and x plus 3 go into x plus 3, so it's a least common denominator. That x plus 3 is going to be part of my least common denominator. But then I also have an x minus 3. So my least common denominator is going to be x plus 3 and x minus 3. They didn't cancel. You just, if they repeat, you only need to take it once. Does that make sense? Like if there was an x on this one and then there was a 2x on this one, we only do x. We do 2 with the x, but we only do x. You only need it to the first power. Okay, so now it's a little different, right? Because my first denominator, what's true about that with the least common denominator? Compare these two. They're the same. I don't have to change 2 at all. 2 doesn't have to get multiplied by anything. I just bring it down. Then I bring down the plus from the in-between plus. And then I go to the second fraction. And when I compare the x plus 3 to my new denominator, what's missing? The x minus 3. And then I distribute. So I'd get 4x minus 12 goes over my like denominator. And then I combine like terms, and I get 4x minus 10 over x plus 3 times x minus 3. You can take out a 2 there because it's a greatest common factor. But if it doesn't cancel, you do not need to do that. So this answer is fine on open-ended. On a standardized test or multiple choice test, you might see it written the second way. Camilla.
When you have to multiply the 4 by the x plus 3 x minus 3, you have to multiply it by x plus 3 and x.
You're only multiplying it by what's missing from its denominator to the least common denominator. So it already has the x plus 3. You just need the x minus 3. Cool.
When you say cancel, what necessarily do you mean?
Like if there was a 4 on the bottom, and I can actually simplify that, then you would need to do that next step. CJ. Because it already has both of these. If they're the same denominator, I don't have to change it. It already has that denominator. Questions on that one? Rodrigo.
Would you have to factor first, or could we do that later?
You have to factor first. Yep. Otherwise, you might have a repeated factor like you did, right? Like what happens if I would have made my least common denominator x squared minus 9 times x plus 3? You would then have to multiply both of them. So it's extra work. And then at the end, you'd have to factor and simplify. So you always want to factor first. It makes it just like you would simplify a fraction before you would combine it. You would make it simplest form first. Okay, last one. God bless you. Is there a denominator that can be factored? Oh.
Yes.
All right, so that last one is the difference of two squares, x plus 1 and x minus 1. Now go through and look at my factors, right? I've got an x plus 1, an x minus 1, and then an x plus 1 times an x minus 1. So when I'm listing to find my least common denominators, all the different factors are going to get made. So I have an x plus 1. I have an x minus 1. I have another x plus 1. I don't need it if it just repeats. I have another x minus 1. I don't need it because it repeats. Now I have to go to each of the three fractions, okay? So if I go to the first one and I compare the denominator with my least common denominator, what's missing? The x minus 1. I'm going to wait and just distribute at the end, but I'm going to just write this out first. Then I go to the second one. What's missing from the denominator on the second one to my least common denominator? X plus 1. And then I go to the third one. What's missing from the denominator to my least common denominator? Nothing. So that's going to stay. Well, let me cross this out. That one's going to stay as 1. Now I'm going to go through and distribute each one. So 2 times x is 2x. 2 times negative 1 is negative 2. I take the plus from the middle. Plus 2 times x is 2x. 2 times 1 is positive 2. I take the plus from the middle again. And this last one is just 1. I didn't have to change it. And it's all going to go over my least common denominator. With me so far? Okay. Now I combine my like terms. So 2x plus 2x is 4x. Negative 2 plus 2 plus 1. These are going to cancel. And I get just plus 1 all over x plus 1 times x minus 1. Can't factor it. Can't simplify it. So it stays just like that. Questions? Okay, so some variations that might pop up. Let's say I get something like 1 over x plus 1 plus 2 over x plus 2 plus 3 over x plus 1 squared. My least common denominator, I have to look at all the terms that are there, right? I have an x plus 1. And then I have it again, but it's not just repeating this time. It's being raised to the second power, which means you have to raise it to the second power. So you have to do it to the highest exponent that's there if it's a repeated factor. So this becomes x plus 1 squared. So if it just repeats and they're both to the first power, you leave it to the first power. But if that factor repeats and it's a higher power, you have to take the higher power. And then I have x plus 2, and so that would also be part of my denominator. So now when I compare them, the first fraction is missing the second x plus 1. So I'd have to multiply this times x plus 1 and the x plus 2.
So you would have to multiply it by x plus 1 squared.
You don't need the squared because you already have one of them. You just need to get it to the squared. Yep. The second one, I'm missing both. So now I'm going to multiply it times x plus 1 squared. And then the third one, I'm missing the x plus 2. So again, if I have a repeated factor, but it is raised to a higher power, you have to take the higher power. And then when you go to look what's missing, you have to multiply it up to that higher power. So like if I was going to multiply this out, I don't even know what this looks like at the end. It might be super ugly, but because I just came up with that off the top of my head. But I would actually have to FOIL these out. So this would be x plus 1 times x plus 2, which becomes x squared plus 2x plus x plus 2, because I FOILed it out. And I'd get x squared plus 3x plus 2. Then I'd take the plus from the middle. And I'd have to multiply this out. So 2 times x plus 1 times x plus 1, because we can't distribute the exponent. You could use your special product on this one, which is square the first, square the last, and double the product in the middle. Or you could FOIL it out. So this would be 2, this would be x squared plus x plus 1, or 2 times x squared plus 2x plus 1, and then distribute. So it'd be 2x squared plus 4x plus 2. And then I'd take the plus from the middle here, and I'd multiply the 3 out to both x and 2. And that all would go over my denominator. And then I would combine my like terms from there. Okay? I would say that's a challenge question. Like, you're not going to see something like that on the test, but you might see it pop up in the homework. So if it is a repeated factor, but it's raised to a higher exponent, you have to raise it to the higher exponent. And then you have to take that into account when you're looking at your original denominator and your least common denominator. Questions?
What was the final answer?
Oh, I would combine my like terms. So x squared plus 2x would be 3x squared. 3x plus 4x is 7x plus 3x is 10x. And then positive 2 plus 2 is 4, plus 6 is 10, over x plus 1 squared times x plus 2. Questions? All right, your web assignment is open.